Okay, we are live. Hello, hello. Welcome, everybody, to the first Java Champions Conference. My name is Victor, and I will be the host of this presentation. And today we are with Rustam. I think that's the right pronunciation. Rustam is a Java champion, also a Google developer expert based on Norway. And today's presentation will be building data pipelines with open source. So please, people, enjoy the presentation, make a lot of questions. I will be monitoring the questions and enjoy the conference. Do not miss the schedule because we will be having a lot of good presentations in here. So Rustam, you're welcome to present, and I'm switching to you.
Thank you very much. Thank you very much, Victor. Great to see you all, at least virtually. I mean, it's the time we live in now. I mean, everyone we see, most of the people we see anyway, are on the screen. So it's great to be here and great to have this fantastic audience. Today, I would like to talk about something that is it's relatively new. I mean, it's not absolutely new, but it's relatively new. And just a few years back, building data pipelines was a very time-consuming way of doing things, and also it was very dependent on a vendor, and kind of not that much open source, not that much, like it was quite painful, and usually you would end up, if you wanted to go open source, you would end up like doing specialized kind of solutions to things. So that's one obvious kind of part of this talk, but I have a tiny little hidden agenda that I haven't mentioned until now, so now it's not that hidden anyway, probably. But the little hidden agenda thing is that I would like to encourage you to try to solve your tiny little problems or bigger problems or whatever that you kind of encounter during your everyday life with some frameworks, and use that as an opportunity to learn something new. So this was a little bit how I ended up playing around with Apache Beam and becoming friends with it. And I would like to share a little bit of that story. But first, I would like to start with, I mean, it's always fun to start with a little bit of a demo, right? So I would like to start with a tiny little demo and saying, it's a very gimmicky, just bear with me for a second. Just, it will be over very soon. Hey, Google, what's the bike availability near me right now? Let's see if that works.
Availability for this station will be decreasing for the next hour. I would suggest getting your bike within next 10 minutes.
I think we'll do it again because we missed a little bit of the sound. Hey, Google, what's the bike availability near me right now?
There are 5 bikes available at the moment. Based on historical data, the availability for this station will be decreasing for the next hour. I would suggest getting your bike within next 10 minutes.
All right. Thank you very much. So this is kind of the vision, or this place where I wanted to get with this my tiny little project. So now I would like to rewind quite a bit and tell you a tiny little story. So now there will be a little bit of a backstory to this whole project. So we'll wait a little bit more with the code and all this technical part. So the thing is that I live in Oslo, Norway, and here we have this public bike service, which is basically a bunch of bikes that are parked all around the city, and you can pay a very small fee for a yearly annual kind of a membership, and then you can pick a bicycle and go anywhere you want, and you leave at the similar kind of locking installations or whatever, places where you lock those bicycles and you leave them there, and you're a happy camper. You've used the bicycle you got from A to B, and you don't have to worry about locking your bicycle or making it safe not to be stolen or broken down or whatever, things like that. And this kind of services, they exist everywhere. I mean, I've been to most of the places I've been to, I've seen something similar. So this picture you see on the right, the blue bicycles, a little bit darker picture, that's in Oslo. That's the bicycles I was talking about. The other picture with the red bicycles, a little bit lighter picture because that was taken during the day. That's from, I think that was from Belgium. I think that's from Devox, Belgium, when I was there. And I've seen like similar bicycle services in San Francisco, in all kind of in Spain, everywhere there were something similar, and probably there is something near you. But the thing is that the way they advertise it, right? This is pictures from really nice places somewhere around Oslo or in Oslo, lakes and green grass, and it's beautiful and it's fantastic, and they kind of give you an impression of, you can get a bicycle, you can go from A to B, and everything is fantastic. So there's more pictures of that. The thing that those pictures don't tell you is about the period that we're kind of right now. It is actually that. The weather conditions might be a little bit different than what you see. So they might be a bit more like this, and a little bit, a bit more light and a bit more snowy, icy and stuff like that. But fear not, they're actually starting now. They started thinking with the pilot project last year and this year as well, with the special tires on the same bicycles with like spikes, studs, little metal things in the rubber wheels in the tires. So you can actually rent those still in the winter as well. So, but that's not the point. The point is they advertise it that there will be bicycles available. You will be able to pick one bicycle and you go from A to B, and everything going to be happy. Everything is going to be fine, and you'll be happy. But then at some point you actually want to go somewhere. So you buy that membership, you're looking forward to this thing, and then one day you have to go from one place to another. You're like, yes, finally I'll use my membership card. This is really cool. And you expect obviously to see bike lockers, these places where they put the bicycles like this. The thing is that in reality they might look quite often, quite often, I would say, something like this. So this is exactly the same stop with a few hours difference and a little bit different angle. But, nothing. There's supposed to be bicycles there. I mean, the one there, totally full, the other one, totally empty. And that's one problem. The other problem is that when you find a bicycle and you go to point B, and you try to park your bicycle or lock this bicycle into this machine, it might be full. So there might be no empty locks available, and then you're in trouble again, because if you don't return it within so many minutes or hours or whatever that the time limits they say, you'll get fines and things, and you don't really want to do that. So it kind of sucks. So this is now I'm showing you the same angle, full of bicycles, no bicycles, and then you get a little bit sad, right? So you get a little bit kind of now I have to go and pick my own bicycle, and and it's a bit of a trouble, and life sucks, at least in this small kind of scale. But it's a bit sad. But then you realize one thing. You realize, like, hey, you know what? I actually work with IT. I code for a living, so maybe I can solve it with some kind of code, some kind of system, something that can help me with this problem, because bikes are there. It's just they're not at the right place at the right time. Maybe I can predict that. Maybe I can do something about it. You see where I'm going? So this was my kind of train of thought. I was like, okay, fine, let's hatch this master plan of things and see how we can solve this problem. So the first thing was like, okay, well, no bikes available, life sucks, at least at this scale. I'm kind of afraid of saying life sucks just because there are bicycles not available. That's not true, right? But it's not optimal. Let's say that. So what can I do? Where can I find bicycles? Well, I don't really know, because, well, I mean, can I use an app? Because there is an app and there is a web page and everything. Yes, I can do that, but no, not really, because the thing is that it will show you the app and the web page and things like that will show you the now picture. So they will tell me, well, you know what, right now there is one bicycle available 1 minute walk from you. And that's perfect. By the time I'll get there, there will be another bunch of other people seeing the same message. So some of them will be faster than me and pick that last bicycle. And by the time I get there, there will be no bicycles. So that sucks. So now picture is not very optimal for this kind of problem, right? Especially when you're planning to go somewhere and you're maybe limited on time and things like that. So can I use public API? They do have public API. That's fantastic. Can I use it? Well, maybe, but the problem is, again, the app and the web page and all those things are actually using the public API. So they're picking exactly the same data And so again, we're sitting with fresh, like now, right now, picture of the bicycles. But then you realize one thing with data endpoints, you can actually collect data, you can store it somewhere, and you can do some fun with it. You can, process it in one way or another. You can do models on this kind of things, and all these fun things. So the next question would be, I work a lot with enterprise software. I work as a consultant, and most of these things I've done throughout my 15, 16 years of professional career, working with enterprises, huge companies, solving their problems with Java and databases and things, and all those kind of things. Now it's even cloud and all this. So then first thought that hits you, okay, well, I can put it into data warehouse because I've been working with this kind of things. And then you realize that, do I really want to have a huge data warehouse or like a huge thing at home? Because I need servers and everything. Do you understand me correctly? I would love have the idea of having like server racks and everything at home. I might be the only one that might think that's a very good idea in the family or in the home, but the possibility did pop up in my head. But then I realized that that's probably again not the most optimal way of securing a bicycle. Just like having the electricity bill, and the good thing I don't have to pay for heating, right? So when it's winter and everything. So, but anyway, so data warehouse maybe not a good idea. Writing something custom, writing a, Java piece of Java code. I tried not to say JavaScript because that would be a different thing. A piece like a Python script or whatever, I could do that, but then it would be again very, very specialized thing. And if anything changes, it will break, and I'll have to kind of maintain my own code base. And I don't really want to do that either, because that's not where the fun part is, right? So obviously, this is a little bit of a sales pitchy thing, right? So something flexible, portable, and open source. That's a good idea. That's what was happened because I was talking to a friend of mine. He works for Google here in Norway, and he was like, you can use this thing for that. And then I was like, oh, yes, that sounds like a good idea. Hold on to that thought. I will say a few words about myself. Just a very, very brief introduction. So Victor did the introduction of myself already. So my name is Rustam. I live and work here in Norway, in Oslo. I work for a company called Pardos. I am a Java champion and also a Google developer expert for clouds. So the thing I'm going to talk about is this kind of Lambda architecture that I started putting together when this kind of train of thought appeared in my head, right? So I was like, okay, I can use this framework and I can do this. It all started with putting things on a Raspberry Pi on the table on my near my sofa in the living room. So basically I had the tiny little Raspberry Pi running this thing 24/7. What it would do, it would wake up every 15 minutes, so 4 times an hour. It would wake up, dump the data, store it to the files, and kind of do nothing for another 15 minutes. Then it would do the same thing again and do nothing for another 15 minutes. So, and it's been doing that for 24/7 for quite some time. And this was this architecture of the whole thing. So basically I had some kind of cron job. It was Raspberry Pi running Linux. So it was a cron tab job that would wake up, do a very short request to REST endpoint, store files down to the file system, and go to bed, go to sleep. So here I have the batch part, right? If you look at this image. So then idea was to have something like Apache Spark or anything else. That was the first kind of iteration of the whole thing. To process this data, to convert it to something that I want to use and put it into database, and also denormalize this data to do some easy reporting on top of that, because there are two different endpoints. I'll get back to why and what kind of endpoints they are, but I wanted to put those two data from two endpoints together and denormalize it so I can do much easier reporting, because reporting was the thing for this case, right? But then I was also wanted to have something that might potentially handle streaming as well. So if I wanted to do streaming with the setup I had with this kind of Lambda architecture with my Raspberry Pi, I would probably need to have some kind of queue or something that would produce that stream, and then I would put it into something, I don't know, say Apache Storm or something else. There's a bunch of now tools available, and put it into a database and visualize in some kind of dashboard, right? And when I put it into the database, in both cases, I will be visualizing it in one way or another in a dashboard, or just showing the table, or just having Jupyter Notebook, or something. But then I wanted to do this version 2.0. So that's where I learned about the Apache Beam, and then I realized that I can actually create models both for batch and for streaming. And yes, I'm getting there. I see the question. What's the name of the open source network framework? You'll see that. It's next slide. I'm kind of building this suspension a little bit. This is suspense. Sorry, not suspension. So I wanted to do the batch and streaming together in one tool, just by building a little bit different models, or actually being able to handle with the same model two different inputs. And then I obviously want to put it into database and into something that would visualize it. I said Jupyter here. It could be anything else as well, right? So enter the Apache Beam. In case you wondered what framework was, that is that thing. So what it is, it's actually originally developed by Google, and they open sourced it some years ago, quite a few years ago, and it's actually pretty cool, a little thing. Actually, not that little anyway. So it can do both batch and stream processing. It also supports quite a few languages. Originally, it was written in Java, and it was like the first versions and were Java. And there is still very, very well maintained SDK for Java available. A little bit later on, they started developing the similar functionality in Python, the Python SDK. And then I think it was somewhere mid last year or so, they announced the Go SDK as well. The cool thing is that you have this central engine, call it in a way, you can call it probably an engine, where all these models are being processed. And then you can plug in things into it to when you need to read things from different media, like say if it's a disk, or if it is, say it's Google Cloud storage, or AWS bucket, or things like that. Anything really. It supports quite a lot of different things. So you can read from things, but you can also store to very many different ways of, like, it can be different databases, it can be some kind of data warehouse stuff. So it has these plugins for input and output and all those kind of things. It's really cool. The other thing also, you can also run this engine on different ways. I'll get back to that a little bit now in a second, actually right now, because what you see there are multiple runners. That's the thing I'm talking about. So you have a direct runner that is your local machine, so your laptop, your whatever you're running your Apache Beam code on. Then very good for development, for also running smaller jobs and stuff like that. If you need a bit more not exactly processing power, but if you need more parallelization, so bigger, more machines, number of machines, you can put it into the cloud. So there is a data flow running on Google Cloud, which is a managed version of Beam. So it's exactly the same thing. It's just managed for you. You can move it to other clouds and just do the same thing kind of yourself. So it's not locked to any specific clouds. It's just, you can do it as you wish. And then there is also like things like Apache Flink, Apache Spark connectors and everything that would let you store things and read things from different endpoints and do that. So where this part of swapping out the components comes in? Well, the thing is that you can read the data and store it to different things, as I told you. So it can be, for example, some kind of pub sub service that you see on top there. It could be Kafka. It could be something else that will be able to kind of push the data into it. And on the other side, it's just storing things and everything. It could be, I don't know, S3, like Amazon AWS buckets. It could be GCS, so the storage on Google. It could be Hadoop. It could be other things, right? It doesn't really matter. So now you can actually upgrade this model. So I have this, the same big picture architecture thing, cron job, batch streaming into Apache Beam, and then into some kind of data warehouse and analysis. So I was running this kind of thing for quite some time on the Raspberry Pi and / my laptop. But then I realized one thing, I was forced to realize one thing, was that my Raspberry Pi died. Because, it's an SD card in it, and basically that's the disk of it. And it does not really like to be written and read to that many times a day. So 24/7, 4 times an hour, 24 hours a day for many months, it did not survive that. So it died. I did lose a little bit of like few months worth of data and stuff like that. So it kind of sucked. So I wanted to do something about it. So then I realized that what if I actually move it to a cloud? Again, this is a GCP version. It could be any other cloud. It's just because this is the cloud I've been working mostly with, and this is what I know. So this is what I built on. This was my hobby project. So I wanted to learn one thing, but not like many other things. So that was the Beam I wanted to learn in this case. So here I had a cloud function of some kind of Lambda function that all clouds have that would do this job of waking up and doing things 4 times an hour. I would store it in a bucket. I would put into this processing data flows, a managed Beam job, and put it into a data warehouse. In my case, it was BigQuery, just because it was like fast and free, because it's like so little, relatively little amounts of data that didn't really cost me anything. And then I would just preview it in something. So that was cool. So now that the model and know the idea, now I want to go a little bit back and go into this Apache Beam thing. So Apache Beam thing operates in something they call pipelines. Pipelines are, what is a pipeline? Well, pipeline this is a definition from Wikipedia. It's always fun to put definitions of Wikipedia. I'm not going to read it aloud because it's long and it's not really kind of presentation friendly kind of text. So think of the pipeline as a conveyor belt, right? You have lots of bolts and pieces and parts on one end. You put them all in the conveyor belt. There is a lot of magic happening along the way, and at the other end of that conveyor belt, a car pops out, right? So think of it like this. So the important things to think here is that pipeline is a graph. It is a directed graph, so it has a direction, right? You cannot go back in this kind of conveyor belt thing. It just goes from one side to another, and it's also acyclic. So there are no cycles. So, if you would have cycles, you would be able to go back, right? So you don't want to do that. And you don't want to kind of go into a loop there either. It's not a point. The point is to convert data from something to something else. And that's what you do. So how do you do that? I want to show you some code, and I wanted to show it some quite simple, because since this is a relatively introductory kind of level talk about the Apache Beam, I wanted to start in very kind of simple manner. I have a little bit more advanced version in this example of the bikes and everything that I'll show you in a second, and also I'll give you the link to GitHub repo where all the code running code will be, and you can try it yourself as well if you want. So before we go into the code of the pipeline, I need to explain you how the data looks. So the data looks like this. So it's basically one of the endpoints, and let's focus for now on one endpoint. I will introduce the second endpoint that I was talking about in a few slides. So for now, think that we have one endpoint, and that gives you only data about availability of the bikes. So you have an ID for each station, this place where all these bikes are locked to. You have information about availability of bikes, so how many bicycles are available, and you have information about how many locks are available. So that means if you have one lock available, you can park one bicycle there. If there are 10 bicycles, and so on, right? And well, availability of bicycles is kind of self-explanatory, right? Overflow capacity, don't really think about that, but it's another extra parameter that you need to think about. Basically, it is when they fill up the bicycle, those racks for the bicycles, they always leave, if that overflow capacity is true, they will just leave some locks on without the bicycle available, so you can actually put your bicycle when you come there. So this is what it is, but don't think about that. It's just an extra, think of it as an extra parameter that we need to capture, right? So I wanted to convert this kind of thing into this. So I see the rows there, I see the IDs there, I see the availability of bikes, availability of locks, availability of overflow capacity, and some kind of timestamp. Because if you look at this JSON object, you'll see that there is no timestamp here. The reason is that this endpoint is a little bit weird one. It kind of returns you always all information about all stops at all times. And there will be only one timestamp at the bottom, at the end of a really long JSON file, and it sucks. So I wanted to convert it to something like that. So I wanted to have a timestamp for each entry. And since I've been doing it 4 times a day, I would 4 times an hour, 24 times a day, I would have quite a few entries per each station, right? And that's an important thing to have a timestamp there. So that's what the way I built this pipeline is that it's very simple. So this is very, very simple, kind of simplified version of that. You have a bunch of input files, right, where I dumped all those things into a file system. And then I read it from that file. I process it. I do a pardo. I'll explain what pardo is in a second again. It basically stands for parallel do. And then I do some kind of magic with it. I convert the data, I kind of massage the data the way I want it to be, and then I store it to a data warehouse. And then, well, it's available in the table. It kind of materializes in the table on the other side. So now I'm converting text files into a database table. So the first thing you would do, so now is the code time. So now you'll see some Java code. So the first thing you will have to do is to define some options. Options is, you don't really have to do that. You don't really have to do them like very extensively, but it's very, very nice thing to do, because it will, you'll be able to provide quite a bit of data. You'll be able to provide some data about things like where to find files. And if nothing is provided from the command line, what's the default value and things like that, right? So you have actually, you can also do descriptions, and those descriptions will be quite useful later on, because you will actually see and understand what is happening when you actually visualize the pipeline. So you can do descriptions, and also for yourself, it's also very, like, after a few months, you go back to your code and you're like, what was that variable and everything? So you can actually do a description. You do default strings. So if nothing is provided, we'll use that string, for example, where the files will going to be. And there is a lot of other things. I just showed you a very short kind of part of this pipeline options. But the point is, you define some options with some default values and some descriptions and names and everything. Then you create a pipeline, and that part is very, very short. It's just one line. Pipeline equals pipeline.create. Then you push into these options that you have created, right? The previous object, put it into that. All right. So now we can do the fun part. Now we can start actually applying transformations. So you remember this thing of the conveyor belt where a lot of magic happens. So this is, now we put things in the conveyor belt. Now the magic starts. So here we can actually call each transformation, we can call it with a name. So we can give it a name. So for example, in this case, it's like first we do read pipelines, or read pipeline where it says read lines, station metadata, input files, a bit long name, but it's descriptive anyway. And here you can decide what you want to do. So in my case, I'm reading it from file system, so I do text IO. There will be other classes for other options, but for this case, text IO. Then I create this metadata object where I can actually do massaging of the data and everything in the next step, because I have this function that will do this formatting and everything. And in the last one, I basically write it back to file. So this is still not the one pipeline that I showed you. It's reading from file and writing to file for now. Now I want to talk a little bit about the Pardos part. So Pardos stands for parallel do. So this is the element-wise transformations. There are a few things, the very important things that need to be considered when you do those Pardos, when you put things into Pardos, is that obviously they will have to be able to be run in parallel. So you cannot have things that depend on the other things, and that it has to be possible to run it on different threads, on different machines, and it will still be fine. So in my case, it's perfect because I have a bunch of files. I have a lot of files. So if I do give each file to one of the processes, I don't care, because that file contains all the information I need. So, it can process the file and dump it to wherever I say it's to dump the process data, and pick another file and process it. And all the other machines can do it in parallel, which is cool. The way Pardos work, this is a very simple piece of code, where you can see actually what's happening. So here I'm picking up this file. I do this new extract from JSON there in the middle. That's what actually does the job for me. So it reads the JSON file. It uses some libraries to serialize that into objects. And then I have an object that I want to put this data into. I do that, and I return it. So again, this is a piece of code that has to be able to be run on many machines, many parallel processes and stuff like that without breaking anything. So now that we have created pipeline, we've created this parallel do thing. Now we need to run it. So running on your machine, that one, I was using Maven for running that, and it's pretty easy. So as you see here, this is local on my machine. You just provide a few parameters. So first I do say I want to have a direct runner. So direct runner, again, as you remember, it means running it on my own machine. So I want to have it on my local machine. I provide what is a main class. I provide some arguments. You remember this option things, option class that we created. If you want to overload some of the values and stuff like that, that's where you put things. So input file, for example, is different here. And then I define what's going to be an output. So this is the pipeline where I was putting things back into the files. So this is output. Here would be the name of the files that would be created. So it would be bike data local dot something, I think, or the folder like this. So that's cool, right? So this works, and now I verified that everything works on my machine. But remember, I still have a lot of data. I've been collecting data for, I think, in total around 3 years now. So 365 days times 24 times 4, so 4 times an hour, and times 60, because no, wait, you don't have to. We're still in hours, so that's fine. Yeah, so that's quite a lot of files, right? But that's okay, because I can either run it on my machine. It will take some time, but it will do, and it will also try to parallelize it as much as it can, like different threads, different cores, and stuff like that. But you can move it also to the cloud, and this is all you need to do is to move it to the cloud. I did not do anything to my code. My code is exactly the same as it was. I just had to add a few parameters. So now I'll do this thing that you never usually do on the presentations. I'll go back and forth on my slides just to let you compare the difference, right? So the only thing here, I added a few extra parameters. I changed the direct runner into data flow runner, and then I added a few other things like which bucket it has to be storing things, which region my data center or which data center region I want to use, and things like that, right? That's all. No code changes whatsoever, and that's really cool part. So that was my pipeline version number 1. So now I replaced this thing to writing to files to BigQuery write. So you can see that here I do read lines, I do this transformation, mapping elements, and everything. Now I'm actually storing it to the database. As you see there, it's like next to last step is BigQuery io.write, and then I kind of finished the whole thing. So this was done in 2019. So well, what is now? Almost 2 years back, 1.5 years back. No, 18. Sorry. So it's more than that. It's 2.5 years back. Sorry. So that was my first version. I think back then I had probably 7-8 months worth of data, I guess, something like that. So it wasn't that much, but still I could process this thing in 18 minutes. So you can see there it says elapsed time 18 minutes 40 seconds, and it used how many machines? It used 17 machines to process that in 18 minutes. And cool. Okay, now I could actually see that, right? And then I was actually able to produce 1.1 million rows of data, which is not even close to big data. I mean, it's nothing to brag about, but still, it's 1.1 million rows. It's just 35 megs. It's tiny little data set in the scale. But, that was a start. That was a good start. So now I wanted to advance a little bit. And now I want to show you a little bit more advanced features here in Apache Beam. And the features are that when I have 2 endpoints now, and I want to do a join of those 2 when I kind of convert all that. So I want to read one, read the other one, and I want to put that data together to denormalize my table even further. Because, I mean, if you look back to the data I had here, I just had an idea. I had no idea where that stop was and what that stop was even called. Now I want to put names into that thing. So now we have, on the left side, you see the data set that we've been talking about. So we've seen that one. But on the right side, you have another data set that has metadata about stations. So it has a station name, it has a coordinates where it is, like geographical coordinates. It has a name and description and subtitle and number of locks available. There's a bunch of data. So I wanted to keep all that data, most of it anyway, and put it into my fantastic database. So now I wanted to have something like this. So now my table is getting wider and wider, and that's okay because, I mean, I'm putting it into data warehouse, so I don't care how wide it gets, as long as I can run some kind of analytics on top of that. So I wanted to add some coordinates. I wanted to add a name and description and things like that. And also I wanted to add some more data, like number of locks available and things like that. That was for other cool things that I could do with it. Because if you have number of locks and if you have number of available bicycles and number of available locks, if you put those 2 available data together, so availability of bikes and locks, and subtract it from number of locks, you will actually get a number of broken bicycles or bicycles marked as broken. And that's already a little bit of data mining and fun things like that, right? But let's not go there. It's just like curious, fun fact. So this was my second iteration. So now I had 2 files 4 times an hour, 24/7, and so on. And I had, now we are a year later. So now this is, you see at the timestamp there, now we're in 2019. So now I had 600 megs of data of files to process. I mean, obviously those files would get in a smaller size when you put those two together because there is some redundancy and stuff like that, but still 600 megs of files to process. And my pipeline now looks a bit different. So now I'm doing this cool thing called group by key in the middle there. So I start two different pipelines. I read both of the files. I do some kind of transformation and like serialize the JSON into objects and stuff, and something that Java can understand. Then I do the group by key. Basically, it's almost the same as you would do join in database tables in a way. Think of it like this. It's not really, but think of it like this. And then I do this Pardos and processing and like, do some crazy stuff with my data, and then I write it to the database. Now you'll see that I actually processed much more data. So remember, 600 megs, so almost at least one, maybe 1.5 years worth of data back at that point. I processed that in 14 minutes. You remember the previous one was 18 minutes? Now I'm actually at 14 minutes. But the thing is that now I used 160 machines to process that. And that was a bit, it was pretty cool. Because thing is that if you, the more you process, the less you feel this startup time, because it always takes some time to kind of schedule the jobs, to realize how many machines it needs, and do all this kind of back office things. And the more data you have, the less you will notice it, because like with little data, I noticed it quite a bit with 18 minutes. Now I had much more data. It actually went faster because it realized it used the same time to start up, but then it scaled down 10 times, scaled up 10 times more, and then was able to process much more data. And that's pretty cool. So now I had this thing, and now I was actually sitting with 13 million rows of data. Remember, before I had 1 million, now I'm 13. And the table size was actually quite decent. Now I'm at 1 gig of data, so 34 megs before, now it's 1 gig. So that was cool. But then I did not really think of one thing. And the thing was that I got notification, and the billing is a bit difficult, a bit weird. Sometimes it takes some time to show how much money you actually spent, and I didn't really think about that. I just run the job, and I didn't think about it. I was like, oh wow, 160 machines, that's going to be fun. And then I got this on my billing account. So I was like, you use like 900% more than what you've used previously. So I got a little bit scared. So I have a little black box on the amount of euros that actually costed me, because I'll leave it to, I would like to see if you can guess. I usually let people try to guess what it is before I kind of reveal the number. But it was a little bit nerve-wracking, because I had to wait for, I think it was almost overnight or something before I actually could see how much it was. So think of a number. Think of a number. Think of a number, goes once, goes twice, goes 3 times. Yes. So that was the number. So that's pretty much a price of, I don't know, a coffee, maybe 2 coffees here in Norway or something like that. So yeah, well, I see somebody writing 15. Yeah, well, no, try dividing it by 4. So the point is, I mean, it's not really point of showing how much or how cheap it is or whatever. The point is actually to show you that it doesn't have to cost much. It can be very, very cheap if you do it right, if you do it in the way kind of that is optimized for that. It could be different clouds, it could be anything like that, but still, And you see here, this is kind of the printout, how much things costed. Actually, the storage costed me a little bit less than €1. Rest was actually the processing. And the other things don't really cost me. BigQuery was nothing, and all the other things, which is cool. And then you get this a bit amazed, because you get this, you remember we had this sad puppy, now we get a little bit into this kind of amazed monkey stage, you're like, oh wow, this is cool. So now we have what I've shown you. So I've shown you this part, right? I've shown you to going from batch into the data. Now I would like to use a little bit of time on a little bit hypothetical kind of version of that, but I'll still be showing you, because I mean, remember, the point is to show you off Apache Beam, not really my project. This was my kind of learning curve. This was my playing around. But the idea is to explain you what you can use the Apache Beam for, really, because This is the point of the whole thing. So now I would like to do a hypothetical thing. So say my bicycle API at some point starts streaming data instead, or if I want to add some data of like weather data or something like that to my data warehouse thing, and I want to do process streaming. So now I have to do a little bit different. So now we've learned the batch thing, right? We had like a daily or hourly or something like that bunch of files. So now we're going from this to this. And this is like a continuous stream of data. It's like a river flowing with full of data. And the problem here, one of the main problems here you would see is that you have unknown delays. You know, it's not, you cannot expect that all data for, say, 8 o'clock about all the bicycle stops appears at 8 o'clock. It might come later. It might come, it might be some problems, it might be some connectivity issues, whatever. It might just come a bit later. So data about 8 o'clock might have actually arrive at 8 o'clock, but it also might arrive at, I don't know, 8:30. It can also arrive at 2:30. And you have to handle that, right? Okay, there is a question: which service is responsible for spinning up those machines? So this is a managed version of Apache Beam. So it's called, the one I was using called Dataflow, but you know it will depend on the whatever you're running it on. But it's I'm on spinning on machines on the cloud. That was Dataflow. So it's a product, but basically a managed version of Apache Beam. That is, yeah. So all you pay is really machines, renting machines, like CPU capacity. And to do this kind of thing with the streams, there are a few things that you need to consider, right? You have to think about transformations. You have to think about windowing. So you need to kind of, if you want to process data, you may want to have some kind of window that you kind of use to pick your data to process it. You want to maybe add some watermarks and triggers that would trigger when specific kind of data occurs or arrives. And you want to maybe to do some kind of accumulation, stuff like that. So transformations. So there are a few different ways of having those or looking at those transformations. It can be very simple. You convert one thing into another thing, and that's all you do. So you convert all the squares into all the circles and triangles. That's all you do. It could be also aggregating. So you see all the squares and you see all the green squares or the red squares or the yellow squares or whatever, and you put them all together in one bucket. All the green ones goes in one and red ones goes in the other one, and so on. But then you can also do a bit of like a bit of everything. So you do some transformation, some counting, some putting together, some everything. So you can also do composite transformations as well in Beam. Windowing, that's basically what you do. You, for example, you can window by time. That's the most kind of probably common thing to do, but not the only way of doing that. I'll show you why in a second as well. So, you know, like this, you will just have a stream. You'll put things like grouping things into like, for example, by hours, by time. That's what I told you. So sometimes you don't really want to put your data into like windows based on time. Sometimes you might want to do, for example, if you're doing a game or something, you might want to do it per session instead of per time. You don't care when the person played. You want to know who played that thing, right? Or something like that. So just a kind of little bit of word of caution or things like that. So this is a short introduction into the streaming part of the same thing. And you can build models on top of that. You can write the same way as I showed you with small modifications, of course, but it still would be able to process the streaming data as well with quite a few cool things. And now I would like to, speaking of cool things, I would like to mention a few. So one of them is when we're talking about windowing, it might be a little bit kind of scary to think that, oh, I had to implement this whole windowing thing. You know, say I want to have, like in this example, you can just do it in one liner that I kind of separated for the readability reasons. So here I want to have a window of 5 minutes, so 5 minutes window, and I want that window to move every time by 1 minute. So every time I move it by 1 minute and look at it. If you have to implement it yourself, that would be a little bit of a pain. If you use the library that the Apache Beam for that, you can do it like this. It's just basically a one-liner. Another thing that I realized that was bugging me for quite a bit was that if I used some kind of fancy cloud, I would get really fancy visualization of things. Like, as you've seen, this little boxes with little nice lines and colored lines and names and things. And that was really pretty. But to do that, I needed to go to the cloud. I needed to deploy to the cloud. I didn't really like that because, sometimes I would develop a pipeline and it would be really tough to know and to keep the whole bits and pieces in your mind. So it was a little bit confusing. So sometimes I would create a pipeline, I would deploy it to the cloud, and it would look totally different from what I thought it would be. And I had to kind of, stop the jobs and kill all the processes and just, and go back to the drawing board and kind of rewrite the code and do things, and got a little bit messy, especially when I was just learning Apache Beam, because Apache Beam has a little bit of its own way of programming, right? It's somehow reminds you a little bit of functional programming, or where you kind of have to think of separated functions, and they always kind of get some input or return something back and things like that. But it's the programming model takes a little bit of time to get used to, right? So I wanted to visualize that locally, and then I realized that there was a little bit slightly undocumented or kind of underdocumented version of that. I went on the mailing lists and I asked it about things and everything. So I realized that you can actually dump the pipeline into a dot files. And dot files is kind of standard for visualizing graphs. And here I could actually, with just 2 lines of code, really, I could dump it into a dot file, and then I could do some kind of visualization of that dot file. So what you see on top there on the image there, very small, and that's not the point to make it bigger and to make it readable. It's just to show you an example of how it looks. It's not as pretty as you will see on a cloud, but this is raw data. This is not, I haven't done anything with it really. But you can modify that file because it's text-based standard. And so you can modify it and you can make it pretty as well. So I did write a blog about it because it was not really documented that well. So I did write that and, spread the word, spread the information, and this kind of thing. So this the link there on the bottom is to the blog post about that. Another cool thing is that you can, as I mentioned already, is that you can replace some of the plugins with something else. So, for example, as I showed you earlier, I wanted to replace writing to a file with writing to a database. Right, and this would be something like that. So imagine that you have this pipeline, you have a bunch of apply methods. This apply methods, this is what apply transformations. Now I want to remove those 2 bottom ones because they are the ones that doing things, storing things to the file, and I want to replace that with storing things to BigQuery. So that would be just remove 2 applies and add 2 other applies, and that's it. Pretty much. Well, that's a little bit of a lie because obviously, since you're using a database here, you will need to create some kind of schema. You need to create some kind of data schema of where and how the table should look like. So you need to do a little bit of coding for that. So it's not just those 2 lines. It's a little bit of setting up the data and everything. But this is as expected. This is what you would normally kind of expect from any kind of database, really. And another cool thing was that you could redirect those pipelines to anything you want. So then when I was showing this to a colleague of mine, he has this database that he loves. He's like, his most favorite thing in the world, I think. At some point it was anyway. It was called ArangoDB. There was that's an open source database, but it has some cool features as well. It does a lot of it has some bells and whistles. And he was like, hey, can you give me the stream? Can you give me the data? I want to do some cool things with it. So I did give him the output of my pipeline, and he kind of put it into ArangoDB, clicked a few buttons, and then he got this map thingy out of the box, because ArangoDB apparently has a plugin which you can just, point it at the table and say where the X and Y coordinates are, and it will just draw you a pretty map. So, and then it, like, with a very simple UI at the bottom with like 3 buttons, searching for a station and showing some information and showing average availability over, I don't remember, or over all time or over a week or something like that. So, the point is that you can do with these pipelines, you can redirect them and do a lot of different things with what you want. And now, kind of going back to the whole story, was that now we had 13 million rows. It was still 2019. I still did not show you the all data of 2020 that I had, and also a few weeks of 2021. But still, already I had 13 million rows of data. Now I could do some fun things. So now I could actually do analytics on top of that. So I put that thing into BigQuery, and I did, for example, this is average availability of logs grouped by month, day of week, hour, and station. Yeah. And the queries are, that's not very readable, and that's the point of it, because they are very long, and this is just a tiny little piece of that. So, it's been a while since I've been writing complicated queries, so probably those can be made a bit prettier, but it worked. So then I could actually calculate average availability per weekday, and then I would know that it would be like more likely to find a bicycle on a Monday than Tuesday or Friday. And you could do a lot of fun things with it. You can find, for example, all the bicycles that have been that has more the most broken bicycles on a station. And actually, we found that, and that was another fun fact, because we realized that there was one station that had insane amounts of broken bicycles, and we were like, what's the deal with that? What's up with that? And then we looked at the map, we looked up that station, and then we realized one funny thing. When we looked at it at the what's it called? Google Earth, or Street View. We looked at that, and then we looked on the other side of the street from this bicycle rack. It was the bike shop, repairing shop for those public service bicycles. So basically what would happen was that machines would come, cars would come with the bicycles, dump them into that lock, mark them as broken, and then the people would kind of pick them up and repair and put them back. And that's why it was so many broken there. And so then, it's a little thing, but it still made us realize that, well, our reporting thing was actually working. And then we could do trending, we can do a lot of things. So you could do things like you heard in the beginning that would say, hey, you know what, the trend for availability is going down. So if you want to get a bicycle, maybe you might consider going out of your home a bit earlier and grabbing that bicycle instead of, going out at the time you want to go and, having no bicycles at all. So, and then you're back to this amazed kind of monkey thing. So because when I got things working, when I realized how the programming model worked and everything, then it was very simple, and it was like, wow, this is too simple to be true. And then at some point I was like, what am I doing wrong? Why it's so simple? And this is really cool. And I kind of let myself brag a little bit about this framework, because it's an open source, it's free, and I would like to have more people using it, and it's really, really cool. A few things that I like, few words of warning, because and that does not really apply to specifically to Apache Beam, but it actually applies to all kind of this, call it ETL jobs, right? It's like it's somehow extract, transform, and load kind of jobs, right? The thing is, your data model is still written there. If your inputs change, it will break things. So what happened was that for some really, really odd reason, this API at some point decided that it might be a very, very good idea to pretty print the JSON when they return it. Instead of making machine readable, they decided it was a very good idea to make it human readable. And it broke my whole pipeline miserably. Like, everything was in pieces, because the thing is that Apache Beam does not like line shifts. It would like to have the whole JSON, like syntactically correct JSON object in one line, because it has to do something with the parallelization and all the other things. So if you have a line breaks, it would just look at the end of the line, look at it, and say, hey, this is not the correct JSON, so I'm bailing out. So this kind of things might happen. This is an example. And other kind of things might happen. They might add new attributes. They might remove some attributes. That's probably even worse. And so your data sources will change. Your data structures might change. New attributes and stuff like that. Sometimes people don't do API management. That's another rant for another time, I guess. But they did change things. Without really, they upgraded new version without letting know that it's a new version, and it broke things. And yeah, so this kind of things is very important to consider when you play around with data and you have some kind of programmatic approach to process that data. It might seem as an obvious thing, but sometimes when you're right in the middle of the whole thing, you might not think about it. So I'm just mentioning it anyway. So yeah, going back to the picture, this is what we ended up with, right? We had a cron job, we had data being processed with Apache Beam, put into database, and then I could do a lot of fun things with it. I did write the whole thing as, well, obviously I tried to solve my problem, which was quite fun way of solving that, but my whole point was to also learn the framework. And the best way of learning it is to look at examples. I did look first at the examples that they provided. They were okay, but they didn't really address my kind of case, and it didn't really, it was a little bit hard to kind of realize what was going on. So then I wrote my own. And then I publish it to everyone as well. So it's on GitHub on this link. So you can actually go and grab the code there. It also contains very simple, short file examples of the data, input data, that you can also run. So you don't have to kind of invent your own data and everything. And with that, I would like to say thank you very much. Thank you very much for listening. I'll see if there are any questions. But I would like to have, like, if you would like to have one here, is that try to learn a new framework, try to learn something new by solving your everyday problems. And this was kind of a little bit my motivation of doing that. This is my playground, coming back from work and just doing some things that you think is fun. All right, let's see if there are any questions. Do you know if there are any? Did you see any questions, Victor?
Okay, I think there is a question. The first one is this one.
Okay, if Apache Beam application, Beam application is deployed in the cloud with 5 machines, let's say, then the batch job triggering every 15 minutes will run each machine or only one machine. Okay. So you don't have to think about number of machines. Basically, you run the pipeline and you let it know where the input data is. And there is internal scheduler that will kind of try to decide the best way. You can obviously override that, but it will try to kind of find the best way of running that. So you basically say, here's my data, please process it. It will look at it, it will decide how many machines it needs, scale it up and down and do that. It will also happen on your machine as well, locally, because it will look at the number of cores, number of threads it can run and things like that. It will also spin off several processes and process it in parallel as well.
Okay.
I hope that answers your question. If not, please ask it again. All right.
Okay.
Next.
There is also a comment here.
Okay. My experience with using data flow for a time-sensitive streaming scenario on production is quite off. Triggers have bug. Pipeline starts very slow. Yes. Yes and no. I mean, the bug part might be, I don't know. I haven't experienced that, but that might be, it might be, and does not even start processing. Yes. So this is, there are 2 things. So one is the bug is that they're kind of fixing it all the time. So that might have been fixed, might not. If not, please report it. There is a mailing list for Apache Beam where a lot of people from Dataflow people there as well. So they will pick it up and they will have a look at that. It might be a bug in Dataflow. It might be also a bug in Apache Beam, because it's just different runners, but the same model and everything. So there might be things. And I did experience some strange behavior sometimes. And with a new version, it would be gone, for example, right? So this thing's kind of evolving all the time. It's as any open source project, I guess. The other thing with the time, a startup time, yes, it is true. I mean, it might be a bit slow, and that's what I showed you already also. When you had the smaller amount of data, it actually took longer time than more data, because it does use some time in the beginning to provision machines, to do a lot of things. But then you can do it in several ways to kind of counteract that. You can maybe you can try to use something else for processing, or maybe you can kind of collect data in smaller batches and kind of push through. It depends on your use case, really. But it works a lot better when you have much more data, even with streams. So I think, I hope that answers your question as well.
Okay.
Do you have any other questions?
Yes, there is a final question. I actually have this question too.
Okay. Any plans to be able to use Kafka Streams as runtime? Well, you mean the Kafka Streams for as a runtime for Apache Beam? I'm not sure, actually. I think they do have. Don't they have? No, wait. I don't know. I have to check that. I'll probably need to get back to you, or I'll need to look that up. I'm not sure if they have the plug the runner for Kafka Streams. They might. If any of you have Google nearby, try Googling it, see if there is a runner there. I can do that as well, but I don't want to type now and kind of get distracted. But yeah, another question I usually get is like, why you're using Beam instead of insert product X? And that's definitely, I could use a product X or like, say, a Flink or something else. But I wanted to learn, Apache Beam. So that was kind of my motivation. And I also wanted to have this, I like the idea of having the managed version so easily available, right? Okay, lots of thank you very much to all of you for listening and for joining in. And feel free to ping me on Twitter or on any other. Well, you see here my Twitter handle was on the screen a little bit back, and also my email and things like that. So it's back now. So feel free to ping me if there is any questions or anything like that. I'll be happy to answer or point you in the right direction. Thank you very much.
Okay, thank you, Rustam. It was a great presentation. Okay, people, there will be another presentations during the evening, so feel free to drop by the channel. Now I think there is also a presentation on Flutter. So thank you, see you guys, and bye-bye.
Bye.